guys, welcome back to another video on Aisha's Academy, and today's video is slightly different. We will be going through a past paper, higher spec specifically from June 2017. My aim is to try and go through as many past papers as possible because I know you guys have mocks coming up or some people have already done them, and I know exams are not really set for this year because of the whole pandemic situation, and also just good revision just so you understand your maths, especially for those that want to go on to do A-level maths this next year, this year, but next academic year, this will be really useful if you understand how to go through past papers. So let's go. Okay, so if we have a look at question one basically wants us to, it says that we have a scatter graph question. So scatter graphs, I do have a video of scatter graphs in the top link above if you want to refresh your memory on those. And I actually have this question in my exam, not in my exam, sorry, in my video as well. So if we move on, with this question, it basically says that one of the points is an outlier. So an outlier is basically a point that doesn't really fit on the graph with all the other points. It's kind of out of place. So that point on this graph would be this one here. And in terms of working out the coordinates, we want to see that where it falls on the x-axis, so it falls here on when it's 10, and on the y-axis, it falls on 19. So in terms of the coordinates, we're going to write it as 10, 19. Why? Because you always write your x before your y value. Think about it because x becomes before y in the alphabet, just to help you remember. And then if we look at part B, it says that for all the other points, it wants us to write down the type of correlation. So because all the points are going up, we call this a positive correlation. So then moving on to part C, it says that on the same sunny day, no, not on the same sunny day, on the same day in another British town, the maximum temperature was 16.4 degrees Celsius. And it wants us to estimate the number of hours of sunshine in this town on this day. So first of all, with an estimate question to do with scatter graphs, you want to draw your line of best fit. Honestly, that's where your first mark is going to come from. So that's my rough drawing of a line of best fit. And then we're going to find where 16.4 is, which is there. Then lastly, you want to draw a line across from 16.4. I know yours will definitely be neater than mine on paper. And then you're going to draw down. And we've got a rough value of 12.8. So that will be our answer. In the mark scheme, it actually says that any answer between 12 to 13 would be accepted. So don't worry if you did not get the same answer that I did. Then a weatherman says it says that temperatures are higher on days when there is more sunshine. Does this scatter graph support what the weatherman says? I would definitely say yes. Why? Because if you've got something that is a positive correlation, then obviously as one point goes up, the other one does. That's why it's positive, because they're both going up. So I would say yes, because as temperature rises, there is more hours of sunshine. Or you could say anything along those lines, like yes, because the graph shows a positive correlation, yes, because there's this more sunshine, the temperature rises. Either way, you would get the marks. So moving on to question two. Question two is a question on prime factors, which I also have a video on that on the link above to do with prime factors, highest common factor, and lowest common multiple. So how we would answer these questions is all about our prime factor trees. So if we draw 56, split it down so we know 2 times 8, 2 times 28 is 56. Circle 2 because it's a prime factor. 28 can be split into 7 and 4. Circle 7, it's a prime factor. And 4 can be split into 2 and 2. So our final answer, you can write it in different ways. They accepted different ways on the mark scheme. So I would normally write it as 2 cubed times 7. Why? Because you always write to the power of how many numbers you have. So because we have 3 2's, that's why it's 2 cubed times 7. Or they also accepted 2 times 2 times 2 times 7. Another way you could have worked it out, let's say if you didn't work it out that way, that's perfectly fine. You could have done 56, break that down into 7 and 8. Circle 7, it's a prime factor. 8 can be split down into 4 and 2. 2 is our prime factor, and 4 can be split into 2 and 2. And notice how we got the complete same answer. So it doesn't matter which way you do it, as long as you get the right answer. So Moving on to question 3, we have a multiplication question. However, we've got it with decimals, and no one is a fan of multiplying decimals. So unfortunately, you cannot use your calculator, so we're going to use a way of working this out. What I would do is change both of those numbers into whole numbers, because we love dealing with whole numbers. So we're going to move both of them forward one decimal place. And there's a reason why I've made note of that, and I'll tell you towards the end. That's going to change both of the numbers to 546 and 43. Now, the method I would use is the column method, but there's other methods you could use. You could, per se, if you want to split up 43 into 40 and 3, and then multiply that to 546 split into 540 and 6. So you could do it that way as well. Or you could also do the Chinese method as well. That's another method that some people are a fan of. So if we write 546, and then we've got our 40 and our 3, and then you can do it this way as well. So either way is best suited for you, but for this video I will be doing the column method. So column method, 3 times 6 is 18, 3 times 4 is 12 plus the 1, which is 13, carry the 1. 3 times 5 is 15 plus the 1, which is 16. Then, because it's 43, because it's 4 t's, we're going to add the 0. Then 4 times 6 is 24, carry the 2. And then 4 times 4 is 16, plus the 2, which is 18. I jumped ahead. And then 4 times 5 is 20, plus the 1 is 21. Then we're just going to add those together. So, bless me. So if we add them together now, so 8 plus 0 is 8. 3 plus 4 is 7. 6 plus 8 is 14. And then 1 plus 1 is 2, plus the 1, which is 3. And then we've got our 2 as well. So far we've got 23,478. Now, the reason why I made note of what was going on up here, of how many decimal places we move forward, because remember, this is not our final answer, because these are not the initial numbers that we dealt with. So because in total we move forward 2 spaces, we are going to move back 2 spaces. And so our final answer will be 234.78. And I hope that made sense to everyone. So always remember to move back, because a lot of people forget that. So moving on to question 4. So question 4 is to do with a question to do with a show that. I don't know why I repeated that, but it's a show that question. So how we're going to work it out. So we're trying to show the area. So remember, never use what you're trying to show in your working out. Remember, you're trying to show that. So area of a square, length times width, right? So our length and width are x plus 3 and x plus 3. So because we're going to end up multiplying them together, because remember, that's what you need to do if you're working out an area or something. And it says our area is equal to 10, so that's going to be equal to 10. Notice how this looks very similar. We're going to end up expanding brackets. Expanding linear brackets, which I have a video up above of linear factorizing and expansion if you need refreshing of your memory on that. So in order to do that, multiply everything by each other. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. One student of mine always says you can do the half moon shape, because notice how we've kind of made a half moon. So then we need to simplify. So 3x plus 3x can be simplified into 6x. So now we've got x squared plus 6x plus 9 is equal to 10. Then to show it what we're trying to show, that, take away 9 from both sides, and we're left with x squared plus 6x is equal to 1. That is all. Right, so moving on to question 5. So we're trying to work out the total weight of the metal frame. So where a lot of students get confused is because it says 5 straight pieces. So remember, you're not just focusing on the border lines, you're focusing on this line in the middle as well. That's how you add up your 1, 2, 3, 4, 5 pieces. So the thing is that we know that this length and this length are 5 and 12, so therefore that would be 5, that would be 12. However, we don't know what this line in the middle's length is, so we need to work it out using Pythagoras, which I have a video up above to refresh your memory if you need. So remember, with Pythagoras, the equation is a squared equals b squared plus c squared. Then in terms of working it out, Oh God, I've written it out wrong way. Is a squared plus b squared is equal to c squared. Our question mark is our hypotenuse, which we always call c, and it doesn't matter where your a or b is. They can be the other way around. So we're going to end up doing 12 squared plus 5 squared is equal to c squared. 12 squared is 144 and 5 squared is 25. Adding them together, they are 169. So c is equal to the square root of 169, which is 13. So we know that this is 13. So now we know that's 13. We're going to add up all our lengths together, which is the 5 plus 5 plus 12 plus 12 plus the 13, which is going to leave us with an answer of 47. Then in terms of working out the total weight, because it's 1.5 kg per meter and we've got 47 meters, to work out the total weight, we have to do 47 times 1.5. And then a way of doing this without your calculator is I would work out 47 times 1 first, which is 47, because anything times 1 is itself. And then 47 times 0.5, which is basically halving it, which would leave you with 23.5. Adds those together, and that leaves you with a total answer of 70.5 kilograms. Okay, so I hope that made sense. Alright, so moving on to part C. So we're trying to show that these two lines are parallel. So remember, showing that is not what you want to start off with, it's what you're trying to show at the end. So with parallel lines, one thing to note is parallel lines have the same gradient. And just to recap, the equation of a straight line is y is equal to mx plus c. And remember, our m represents our gradient, and our c is our y-intercept. So remember, y-intercept is basically the part of the line that crosses the y-axis. So for instance, if I have this random straight line, our y-intercept would be that value that crosses the y-axis. So we don't really need to know that for this question, but just for a recap of straight lines, in case you've forgotten. So because we know m is our gradient, the m parts of the equations need to be the same. That's what we're trying to prove. So the first line is in that y equals mx plus c format, so we're going to leave that the same. The second one we are going to change. So we have 3y minus 9x plus 5 is equal to 0. So how we can change it is the first thing is that we can rearrange. So rearranging, I do have a video on rearranging algebraic subjects and equations on the link above. But how we would rearrange it is if we moved everything over and made the 3y the subject, we would be left with 3y is equal to positive 9x minus 5. Then there's two ways of working this out. You can make them both y is equal to, kind of like the straight line format, which a lot of students do because they find it easier to relate to. And so if we were to do that, we were to divide the whole equation by 3. And if we were to do that, 3y divided by 3 is just y. 9x divided by 3 is 3x. And then minus 5 divided by 3 we can leave as 5 over 3. So we know that line 2 is equal to that. Line 1 is y is equal to 3x minus 2. I've just written it again. And as you can see here, both of the m values are the same. So we could say they both have a gradient of 3. Therefore, that's just the therefore sign in maths, they are parallel. Or you could say they both have the same gradient along those lines. Another way you could have worked out is, so I'm going to put or, is we got left with line 2 as y as 3y is equal to 9x minus 5. So rather than making both lines as y the subject, you could have made both lines as 3y the subject. So we could have multiplied this top equation by 3, which would have left you with 3y is equal to 9x minus 6. And again, the whole point is notice how they have the same gradient. Okay, so I hope that made sense. So moving on to question 7, so we got a bit of mean. So 10 boys, 20 girls. We've got the mean mark for the class and the mean mark for the girls. We're trying to work out the mean mark for the boys. So the first thing is you want to work out the total marks for the class. And in order to work out the total marks is your mean is 60, which means that for each person, they roughly got 60 marks. So first of all, in total, we have 30 students because 10 boys plus 20 girls is 30. So in order to work out the total marks for the class, we need to do 60, because that was our mean, times 30, which is 1,800. Then for the total marks for the girls, we're going to be ending up using the same method, but obviously different numbers. So that will be 54 times 20, which is 1,080. Then to work out the total marks for the boys, we're just going to take away those values from each other, which would be 1,800 minus 1,080, which would leave you with 720. Then to therefore work out the mean marks for the boys, it will be 720 divided by the total of boys, which is 72. So that was that question. All right, so moving on to question 8. So standard form, which I do have a video on the top link above in case you need to refresh your memory. So the first part of the question is that it says that we've got 7.97 times 10 to the minus 6. So in terms of standard form, if you've got times a negative power, what we're going to do is you're basically going to make a small number. So we're going to go back 6 bases, so minus 6 bases. So if we were to do that, so we have 7.97. So what I would do is, because it's a smaller number, I'm going to put loads of zeros in front. But to go back 6 spaces, that's 1, 2, 3, 4, 5, 6. So go there. So our final answer is 0.0000797. And that is literally your final answer. So again, if you want to refresh your memory on standard form, click on my video up above. All right, so with part B, it's slightly different. Part B is going to involve dividing standard form, which I also do have a link above in case you want to refresh your memory. So if we were to tackle this question, the first thing is that you want to divide both of the top numbers. So we're going to end up doing 2.52 divided by 4, which if you struggle with dividing by a decimal without a calculator is the same as half, then half again. So 2.52 divided by 2, aka half, would be 1.26. And then 1.26 divided by 2 would be 0.63. So that's that. And then in terms of the 10 to the 5 divided by 10 to the minus 3, so we would end up taking away from the powers. So whenever you're dividing by standard, or just dividing by powers with the same base number, so they both have a base number of 10, you're going to end up subtracting from the powers. But just remember that here, you've got a negative 3. So you're essentially going to be doing 5 minus minus 3. And remember, whenever you have two minuses together, it becomes a positive. So really and truly, our answer will be 10 to the power of 5 plus 3, which would be 10 to the power of 8. So we're not just done yet, because we've got 0.63 times 10 to the 8. But this first number is not essentially correct in terms of standard form, so it needs to be changed to 6.3. So we're going to have 6.3, and then because 6.3 fits within the range, because remember your first number has to fit between 1 and 9.99. So because we moved forward one space, you have to take away 1 from the power. So it'll be 6.3 times 10 to the power of 7. So again, watch my video in case you want to refresh your memory. Then here we've got Jules, who buys a washing machine. So 20% VAT has been added to the price of the washing machine, making a total of 600. So what is the price of the washing machine with no VAT? So where a lot of students get wrong with this is they'll work out 20% of 600 and take it away, but that is incorrect, because this 600 is the original price of the washing machine, which is 100%, plus 20% VAT. So essentially, this £600 is equal to 120%. And so because of that, 120%. And so because of that, we need to work out what 100% of the price is, aka the price of the washing machine without the VAT. So how we could do that is two ways. You can either do 600 divided by 1.2, and that will give you the answer straight away. Or, since it's a non-calculated paper and that might be a bit difficult for people to work out, you can work out what 100% is so if we did 600, if we know that 600 £5 is equal to 120%. You can work out what 100% is by working out what 1% is by dividing 160 by 120. And by doing that, so if you have 600 divided by 120, take away both of the zeros, you're left with 60 divided by 12, which is a really nice calculation of 5. So we know that £5 is equal to 1%. Then in terms of working out what 100% is, times them both by 100, and you're left with an answer of £500. So I hope that made sense. Right. So question 10, which I actually had on my Instagram as question of the day. So with question 10, what it wants us to do is it wants us to do x plus 1 times x plus 2 times x plus 3. So again, where students go wrong is they see this and they think, I don't know how to work out 3 brackets. But you do know how to work out linear 2 brackets. So literally all you can do is work out what 2 brackets is times each other first. Then the answer of that you can times by x plus 3. So I'll show you what I mean. So I would do x plus 1 times x plus 2. Right? So expand your brackets. Again, watch my video on linear factorizing and expanding to refresh your memory on that. So we'd have x squared plus 2x plus 1 times x, which is x. Remember, you don't write the 1 in front in algebra. And then plus 1 times 2, which is 2. Simplify that. So that would give you x squared plus 3x plus 2. Then we want to do that multiplied by x plus 3. So again, just expand. So x squared times x is x cubed. X squared times 3 is 3x squared. 3x times x is 3x squared. 3x times 3 is 9x. 2 times x is 2x. And then 2 times 3 is 6. So simplifying that, we've only got one set of x cubed, so that's on its ones. Then we've got the 2x squareds in sense of the 3x squared plus 3x squared, which is 6x squared. Then we've got 9x plus 2x, which is 11x. Then we've got plus 6. And we've shown it to be in that format. So that's literally it, guys. Alright, so I hope you guys are finding this useful as we're going along. We're literally halfway through. Okay, so question 11, it wants us to write down the coordinates of the turning point. So literally a turning point is the point on a quadratic, cubic, or any kind of ick graph where it turns. So that would be this point here, because that's where it's turning. So our turning point, again, whenever we're writing coordinates, we write our x before our y. So literally the answer will be 1 minus 3. And then moving on to part B, it says write down the estimate for the roots of when f of x is equal to 0. So just to note, remember if we look up here, f of x is equal to y. So basically we're looking for the points on the graph where y is equal to 0, aka the x-axis, which will be this point here and this point here. So in terms of its roots, aka its, the points of x where it crosses, is this first one here is minus 0.7. So that's the first one. And the second one is 2.7. And that's it. And then part C, it says use the graph to find an estimate for f bracket 1.5. So remember, normally in that bracket, it was f of x. X was in that bracket, but x is being replaced by 1.5. So what you're literally going to do is find where 1.5 is, which is here. Go down to the graph of where that would land, and that would be about there, which is a value of 2.8 on the y-axis. And that's literally it, guys. All right, so moving on to question 12. So a bit of indices. So here we've got 81 to the power of minus a half. So we're going to work it out bit by bit. First of all, whenever you have a negative power, you basically flip it up into a fraction, aka work out the reciprocal. So if we've got to the minus a half, we're going to flip it, and that becomes 1 over 81 to the power of a half. So when you flip it, its negative sign goes. Then to work out to the power of a half is the same as square root. So we're going to basically work out square root of 1 and square root of 81. Square root of 1 is 1. Square root of 81 is 9. And so your answer is 1 over 9. Then for the next one, it was 64 over 125. So to the power of 2 over 3. So 2 over 3 is the same as saying 2 times a third. So what we can do is work out to the power of a third first and then square it. So if we've got 64 over 125 to the power of a third, If we know that the power of a half was square root, so the power of a third is the same as cube root. So we're going to work out the cube root of 64, aka a number that multiplied itself 3 times to work out 64, and same with the cube root of 125. And that would give us answers of 4 over 5. Then we're going to square those. So that would leave us with 16 over 25. And again, that is your final answer. So moving on to question 3. So we have inverse proportionality and it wants us to basically write the equation for that. So in terms of my method for writing down these formulas, I literally break down the sentence bit by bit, aka this sentence that basically tells us what the formula is. So it says y. So I'll write y. Is equivalent to my equal sign, so equals. If it says inversely proportional, then it's our constant k. Remember, inverse proportionality, direct proportionality involves our k constant. And because it's inverse, it's going to be k over whatever it's inversely proportional to, which is the square of x. So over x squared. That is it. However, here it's given us values of x and y, so we can actually use these to work out what our constant k is. So I'm going to use the first pair because they're quite nice and easy numbers. So I'm going to substitute them into what we have so far. So it'll be 9 is equal to k over x squared, so 1 squared is 1. If we rearrange this, k is equal to 9 times 1, k is equal to 9. So therefore the full equation will be y is equal to 9 over x squared. Then for part B, it says it wants us to find a positive value for x when y is 16. So again, I'm going to use the equation that I worked out before to help me answer that. So when y is 16, it will be 16 is equal to 9 over x squared. If I rearrange that, it's going to be 9 over 16 is equal to x squared. If I now square root that, I will then be able to work out what x is. So I know that the square root of 9, so work out what x is. So the square root of 9 is 3. Square root of 16 is 4. And the reason why it said work out the positive value is because whenever you've got a square root question, remember technically you could have positive or negative 3 over 4. Because remember, 2 negatives make a whole number. But because it just wants the positive value, I'm just going to write 3 over 4. So make note of that. And then on to question 14. So basically question 14, we've got white and black shapes and full of circles and squares. And it just wants us to write down the fraction of all the shapes that are circles. So in terms of the white shapes first, so I'm going to put W and then B. So we know the fraction for the white shapes will be 3 out of 10. Why do I say 10? Because if we add the two ratio numbers together, we get a total of 10. And for the black shapes, it would be 7 out of 10. Then we know that the ratio for white circles to white squares, well, for white circles, which is what we're interested in because we're working out the number of circles, the fraction would be 4 out of 9, because again, 4 plus 5 is 9. And then for the black circles, the fraction is 2 out of 7, because again, if we add 5 plus 2, we get 7. Now, in terms of the number of white circles out of everything in total, we can work that out by doing the total of white shapes times the fraction of white circles, which is 4 out of 9. That leaves us with 12 over 90. Then in terms of the black circles, so I'll just put white circles. Then in terms of the, not WB, the black circles, again, we can do the fraction of black shapes, which is 7 over 10, times the fraction of black circles, which was 2 over 7. Times those together. Remember when we're times and fractions, times the top, times the bottom. I've got a video up above in case you want to refresh your memory. So we'd be left with 14 over 70. And then we're going to simplify these two fractions. So if we were to simplify them, so 12 over 90 would be simplified. So we can divide both the top and the bottom by 3. Be left with 4 over 30. Divide them both by 2. We'd be left with 2 over 15. If we divide 14 over 70 by 7, we'd be left with 2 over 10. Not 2, yeah, 2 over 10. Simplify that. So divide the top and the bottom by 2. We'd be left with 1 over 5. Okay, and then the last bit, but not least, we need to add those together. because that's going to find out a fraction of all the circles together. So remember, when we're adding fractions, we want the denominators to be the same. So we're going to change the 1/5 to have the denominator of 15th. So times both the top and the bottom by 3, we end up with 3 over 15. Add them together, we get 5 over 15. Divide both the top and the bottom by 5. We are left with 1 over, not 1 over 5, 1 over 3, aka a third. And that is our final answer. Okay, so moving on to question 3. So it wants us to estimate, give us an estimate for the height. So where this goes wrong is a lot of students will work out what the volume is. Do not work out what the volume is because it has told us up here. So we're going to use the volume and the radius to work it out. The key thing is estimate, and they know you don't have a calculator, so they're not expecting you to work out with these figures in your head. So we're going to round them. So let's round 98 to 100. That's a nice number. And let's round 5.13 to 5. And then for pi, we're going to end up using the value of 3, because 3 is a nicer number for pi when you don't have a calculator. So I'm going to input all the values. So volume is 100, equal to a third, times 3, which is our pi, times radius squared, which is times 5 squared, times the height that we're trying to work out. So a third times 3 will end up cancel out into 1. So that will be 100 is equal to 5 squared times height. 5 squared is 25. And we know 25, we know 100 divided by 25 would leave us with 4. So the height is estimated to be 4. Then for part B, it says John uses a calculator to work out. Unfortunately, we did not have that opportunity, but it's fine. So John uses his calculator to work it out. And we're basically trying to work out that, if it was John who worked out on the calculator, would our estimates be more than John's answer or be less than John's answer? Well, let's have a look at our values. So we had 100, which we rounded up, remember? So we rounded up 100. So I'm going to just rearrange this equation actually to make the height the subject. So we had height is equal to 100 over a third times 3 times 5 squared. So we rounded up our height. We rounded down our radius. We rounded down our pi. So by doing that, if we have a higher numerator and a lower denominator, which is what we did. So our numerator was higher and our denominators were lower. And basically, if you're going to do that, you're going to end up with a bigger answer. And the reason why is because your bigger number is bigger and then the smaller numbers at the bottom are smaller. I'll give you an example. So let's say if we have 100 divided by 20, you get an answer of 5. But let's say we increase this number at the top and we reduce what's at the bottom. So let's change the numbers to 110 and reduce it to 10. 110 divided by 10 is 11. Notice that drastic change. So a lot of times, to not know it straight away, what I would do is play with some numbers as examples to kind of see, oh, okay, this is why it would be more, okay, this would be less, because sometimes it may be hard for students to automatically know whether it would be more or less. So yeah, so our estimate would be more as we rounded our numerator up and our denominator down. Okay, good. So then I'm going to look at question 16. So question 16 is a proof question. So we're trying to prove that it's always an even number. So tackling it down. So the first thing that we're going to do is end up looking at these brackets. So we've got n minus 2 squared, aka n minus 2 bracket n minus 2. So again, more expansion. So n times n, which is n squared, minus 2 times minus 2. Sorry, minus 2 times n, which is minus 2n, minus 2 times minus 2, which is plus 4, and then we have minus 2 times n, which again is minus 2. Simplify, so that's going to leave us with n squared minus 4n plus 4. we had this added on to n squared minus 2 minus. So the reason why I'm putting a minus on the outside is because remember we had to take away from the answer of those brackets. So that's going to kind of change everything up to make them negative. So what I mean by that is you'd end up with n squared minus 2 minus n squared plus 4n, because remember two negatives make a positive, minus 4. Then we're going to simplify. So n squared minus n squared would be 0, so they're going to cancel out. Then we've got 4n. We've got minus 2 minus 4, which would be minus 6. If we make this all divisible by 2, aka factorize, we would be left with 2n minus 3. So in terms of proving that this is equal to an even number, we can conclude that any multiple of 2 is an even number. Or we could say 2 bracket 2n minus 3 would always be even because it's a multiple of 2. Anything along those lines they would accept. But whenever it comes to proof questions to prove that something's even, show that it's a multiple of 2, basically. Alright, so having a look at question 17, we've got 9 counters in a bag, 7 are green, 2 are blue, and it basically wants us to work out the probability that Ria takes out 1 counter of each colour. So the first thing that we're going to do is draw our probability tree. So I'm going to put first and then second. Why? Because she takes out the counter on 2 different events. So firstly, let's split it up. So we had 7 greens. So 7 out of 9. So remember with our trees, always put them as fractions. Then for the blue, it was 2 out of 9. And then for the second time, it's just going to be the same probabilities. But remember, you could have 2 outcomes again. So because you've taken a counter out of the bag, let's say you took out a green first. The probability of taking out a second green, because you have 1 less green, it will be 6 out of 8 because you have 8 in total instead of 9 now because you took 1 out. And so for the blues, it would still just be 2 out of 8 because you didn't touch the blues. Whereas if you took out a blue first, the probability of a green will be 7 out of 8 because you didn't touch the greens. Whereas taking out a blue second after taking out a blue first will be 1 out of 8. So in terms of working out the probability of taking one of each colour, there's 2 ways that we can work it out, but I'll show you the easiest way. You're literally going to work out the probability of picking up a green first times the probability of taking out a blue first. So you have to do that. That's 7 over 9 times 2 of 8. So remember, fractions, you multiply the 2 numerators together, which would be 14. 2 denominators, which is 72. Then work out the probability of taking out a blue first and then a green second, which notice how it's not the exact same, but they're similar fractions. So that will be 2 out of 9 times 7 out of 8, which again will just be 14 and 72. Add those 2 answers together. You're left with 28 over 144, which we can simplify that to 14 over 72. And we can actually simplify that further into 7 over 36. So that is one way of working it out. Again, if you didn't want to simplify it, that's perfectly fine. It says the mark scheme would have accepted Oh, I've just realised. I'm so sorry, guys. Yeah, sorry, adding fractions. Silly old me. Adding fractions, your numerator should never change. So yeah, you would just have 28 over 72. You can simplify it if you want into 14 over 36 if you want, but they would have accepted 28 over 72 as well. So that's one way of working it out. And then another way of working out, if you really wanted to, it could be 1 minus the probability of taking out 2 greens. So plus the probability of taking out 2 blues. So you could have done that way as well. Either way, you would have ended up with the correct answer. So, but that way is the easiest way I can think of. So going on to question 18, it wants us to work out the equation of a diagonal AC. So that diagonal AC, I always like to draw it out. So that is our diagonal AC. We know that the equation of the diagonal DB, put in a different color, is y is equal to a half x plus 6. And what I want you to notice is that these lines are perpendicular. So remember, with perpendicular lines, it's not like parallel lines where they have the same gradient, but perpendicular lines have their gradient as a negative reciprocal. So they have a negative reciprocal. What I basically mean by that is, in this case, our dB is a half. So to make that a negative reciprocal, you basically flip it. That's what reciprocal means. So that'll be 2/1. And then negative, you stick a negative in front. But notice how we have 2/1 and anything divided by 1 is itself. So aka will be -2. So we know that the gradient for AC is already -2. And it's going to be in that format in y equals mx plus c. But we know what the m is now. We know that it's -2. The only thing to make this equation complete is we need to work out what c is, the y-intercept. And how we can do that is substitute the coordinates of A, because we know A falls on the line AC. So if we did that, our y value is 11 and our x value is 5. So if we were to do that, 11 is equal to -2 times 5, which is -10 plus c. And therefore, c would be equal to 21. So our final answer would be written equals y is equal to -2x plus 21. And that is literally it. So, moving on to question 19, guys, we are nearly at the end. Oh my gosh. So, this question is all to do with vectors. So, in terms of working out vectors, remember, vectors are quite interesting because vectors are basically either horizontal or vertical lines. They never like diagonal lines. So, what I mean by that is here where it says O to A, so it means going from O to A is A. And then it says going from O to C is just C. So anyways, it says that we have X, which is the midpoint of line AC. So line AC is there. So the midpoint would be here, X, because this would be our line AC. Again, imagine if that's a straight line. And then it says OCD is a straight line. So because we can see that OC is going in that direction and it's a straight line, we can imagine D would be something about there. Then it says that the ratio of O to C from C to D is K to 1. Okay, and then it says from X to D, we would do 3C minus half A, which basically means, remember, because we can't just do a straight diagonal line from X to D. So in terms of using horizontal and vertical lines, it basically means, so first of all, we can do the minus half A because that's the easiest bit. So what that means is if we know A is in that direction, then negative A will be in that direction. So that's why we get the negative A part. And then the half is because notice how X is halfway between O and A. So that's why that bit is the negative half A. Then in terms of the 3C, that basically means that from that horizontal line, X to D, that is about 3C. So we can see that C is the length of O to C. So that bit would be our half C, if we look, because that's halfway between the line, which basically means is that if that horizontal line is 3C, that means that we need to work out, that means that that bit between C to D is 3C minus half C, which is 2.5C. And the reason why this has made our life 10 times easier is because we know that O to C was C. And we know that C to D is 2.5C. So therefore the ratio would be 1 to 2.5, aka 2.5. So we know K is 2.5. Or you could write it as 2.5. I hope that made sense. Where it can confuse people is because you've got the K first, but notice how ratios can be flipped the other way around. So if it's K to 1, that's the same as saying 1 to K. And as we can see, we've got the ratio that we formed. So that's basically how we could have answered that question in the easiest way. Or another way you could have written your answer and they would have accepted is 5/2, because that's the same as writing 2.5. Okay, and then question 20, we've got quadratic simultaneous equations. So in terms of answering these questions, we are nearly done, guys. So in terms of answering these questions, you always get a quadratic equation on the top and the linear at the bottom. So the first thing I want us to do is rearrange the linear equation into, so we've got y minus 3x is equal to 13. Let's make y the subject. So it will be y is equal to 3x plus 13. So then we're going to substitute y for the y squared there. So it's going to be x squared plus, instead of y squared, it's going to be plus 3x plus 13 squared is equal to 25. Then we're going to expand these brackets. So 3x plus 13 times 3x plus 13. Probably getting tired of expansion by now. So we would have got 9x squared plus 39x plus 39x plus 169. Simplify and we end up with 9x squared plus 78x plus 169 is equal to 25. Take away 25 from both sides. We end up with 9x squared plus 78x plus 144 is equal to 0. Then the next step is that we're going to do, so we've worked out that that's equal to 0, sorry. Carry down the x squared above, so add that to x squared. So then we know x squared plus 9x is going to leave us with 10x squared. Then the next part is we're going to make this nice and easy, so divide by 2. So we're going to simplify this equation, which would leave 5x squared plus 39x plus 72 is equal to 0. Then we need to factorize. So again, to refresh your memory on factorizing, so because we've got 5x squared, we're going to have 5x in one bracket and x in the other. Then we need to think of all the different ways of multiplying to make 72. So we can have 1 times 72, 2 times 36, 3 times 24, 4 times 18, and we can have 6 times 12. So I'm going to try this one. So I would put 24 in there because if I put 24 in the other bracket, it will be way too big of a number. And then the 3, and that seems to work. So if we have that, that would be our brackets. Then in terms of working out the two solutions for x, the first one would be x is equal to minus 3, because remember, because our answer is 0, technically the brackets is the same as x plus 3 is equal to 0. If we rearrange that, we end up with x is minus 3. And then for the other one, if we have 5x plus 24 is equal to 0, 5x is equal to minus 24, x is equal to minus 24 over 5. So then x is equal to minus 24 over 5. And then for our y values, the last bit is we're going to substitute our x values into the linear equation. So for when x is minus 3, y is going to be equal to 3 times minus 3 plus 13, which is going to be minus 9 plus 13, which will be 4. So y is equal to 4 there. And then for the other x value, when x is equal to minus 24 over 5, y would be equal to 3 times minus 24 over 5 plus 13, which will be minus 72 over 5 plus 13. Plus 13 to have the same denominator would change to plus 65 over 5, which would leave us with an answer of minus 7 over 5. And I hope that step to step also made sense. Okay, guys, 2 questions left. So we've got a lovely proof question over here. So if we look down at the marks, so we can see that this is a 4-mark question. The reason why I always say that's important for proof questions is because if I know I've got 4 marks worth, then I want to prove 4 points. So the first thing that I'm going to prove for this question is that the line AB, so the line AB is equal to the line CD, as we have the parallel lines there. So that's 1 mark. And then the second way is looking at the angles. So I know that the angle ABC, always put a hat on the middle of where the angle lies, so because it's around the B, that is where it is. The angle ABC is the same as the angle BCD. And then also the fact that if we look at these triangles, I'm going to draw them in different colors for a reason. Notice how they both share the line BC in common. So I'm going to say both triangle ABC and BCD share BC in common. That is my third mark. And then the last mark, but not least, is basically just concluding. So therefore, you can conclude that. So yeah, the last bit is you want to conclude that stating that the triangle ABC and DCB with reason of the same side. So conclude that triangle ABC is equal to DCB with reason of the same side and the same angles. So therefore, AC is equal to BD. Okay, hope that made sense. And then last but not least, question 22. So in terms of answering question 22, the first thing that we're going to do is basically plot everything out. So it says that AB is equal to BC, which is equal to X. Then it then says that, so if I zoom in, it then goes on to say that P is a point on AF and then Q is a point on CD, such that PB and PQ is 10. So they are 10. Then it then goes on to say how the angle at ABC is 30 degrees. Okay, and then it wants us to prove that. So what we're going to end up doing is drawing out the two triangles that we've kind of semi-formed. So I'm going to draw out our ABC, has its angle of 30 and sides of X. And I'm going to draw out our triangle with PQB, which we don't know the angle, but we know the sides of 10. So what we're going to end up doing is using the cosine rule. So in terms of the cosine rule, we're going to be using it to work out what the missing length of line A to C is. So the equation, just to refresh your memory, is A squared is equal to B squared plus C squared minus 2BC cos A. So we're going to substitute those values. So A squared is what we're working out, aka our A, and then we know what our B and C is. And then the big A is the angle 30. So A squared would be equal to X squared plus X squared, which is 2X squared, minus 2 times X, which is again 2X squared, then cos 30. Then to refresh your memory, the answer for cos 30 is, remember, you need to learn these values without a calculator. Cos 30 is root 3 over 2. So just to refresh your memory. So then going on, so it will be A squared is equal to A squared is equal to 2X squared minus 2X squared cos, I'm going to change that to root 3 over 2. So notice how the line AC is the same as the line PQ. So we know if that's equal to that, then that is equal to that. So therefore, we could also use the cosine rule, but we're going to work out what the A for this triangle is. So if we were to rearrange that equation to make A the subject, aka the big capital A here, the subject, it would be A squared minus B squared minus C squared over 2BC equals to cos A, aka our cos PBQ, because that's the angle that we're trying to work out. So we're getting there. So now we actually need to put this into place. So our A squared was the wham equation that we have. Yeah, it's just the really wham equation that we have. So our A squared, which was 2X squared minus 2X squared root 3 over 2. So then we know that our values, sorry, I've written this all wrong. Yes, So I'm going to rearrange it again properly. I'm just going to do it now quickly. So a squared equals b squared plus c squared minus 2bc cos a. So a squared minus b squared minus c squared is equal to minus 2bc cos a. So yeah, if we were to divide that now, so divide by minus 2bc would be equal to cos a. And then multiply everything by minus 1 to cancel out the minus at the bottom. You'd be left with positive 2bc, but you'd be left with also positive b squared plus c squared minus a squared. Yep, that's rearranged properly. So now I'm going to substitute. I was looking at that. So always do it step by step in case. Don't rush like me. So b squared plus c squared. So this time our b and our c is the tens and our small a is the big long equation. So it's going to be 10 squared plus 10 squared, which is 200, minus the long equation, which is minus 2x squared minus 2x squared root 3 over 2. And then 2bc, which is just 2 times 10 times 10, which is also 200. So now I can split that up into 200 over 200 minus the long equation. I'm just saying that to avoid saying it. Over 200. We know 200 over 200 is 1. And then we can see that the numerator of the long equation, if we take out the common factor, which is 2x squared, that's going to change everything. So that will change it into 2x squared bracket 1 minus root 3 over 2. Yep, take out 2x squared. Oh, because we're trying to make it equal to that, we're not going to take out 2x squared as a common factor. We're just going to take out x squared. So it's going to be x squared bracket, yes, 2 minus 2 times root 3 over 2. Then the last thing to make it equal to what we're trying to make, we're going to, so if you did 2 times root 3 over 2, that 2 and that 2 is going to cancel out, which is just going to leave you with root 3. And therefore, essentially, we've made what we're trying to show. So I'm just going to change it now just so it looks exactly identical to that, which we had our 2 minus root 3, and then just make it to x squared, because that's the same as when the brackets was around. So then you could write cos b bq is equal to that. So that's the end of the past paper, guys, and I really hope that was useful. I tried my best in terms of going through it as, not too quickly, but also as a good amount of speed as possible. Please comment down below if you have any questions or if you thought this was a good video. And yeah, please share, like, comment, and subscribe. And thank you so much for watching, guys.